Have you ever pondered over the nature of light? Is it a particle or a wave? Now, this is not an easy question to answer. You see, light has a dual personality. It behaves both as a particle and a wave, a concept known as wave-particle duality. Let's take a moment to consider the famous double slit experiment. When light passes through two parallel slits, it creates an interference pattern on a screen. This pattern, with its alternating bright and dark bands, is the signature of wave-like behavior. But here's where things get intriguing. If we place detectors at the slits to observe which slit the light passes through, the interference pattern vanishes. Instead, we see two distinct bands of light, as if particles have passed through each slit separately. This phenomenon, known as the complementarity principle, implies that light exhibits particle-like behavior when observed. This dual behavior of light leads us to the fascinating concept of the quantum eraser experiment. Now imagine you could erase which path information. Would the light return to its wave-like behavior? Here's where the quantum eraser experiment enters the stage. This experiment introduces a beam splitter into the mix. This clever device can obtain information about the photon's path without disturbing the photon itself. It's a bit like asking a photon, which way did you go, without actually interfering with its journey. After the beam splitter gathers this which path information, the beams are recombined, and here's where the magic happens. When the paths converge, the interference pattern, that hallmark of light's wave-like behavior, reappears. It's as if we've erased the particle-like behavior of the photon, allowing it to return to its wave-like state. But this isn't just a simple magic trick. The quantum eraser experiment challenges our understanding of causality. It suggests that the behavior of a photon can be altered after it has made its journey, a concept that requires a non-standard view of quantum mechanics. There's one more twist in this quantum tale. These effects, the erasing and the return of the interference pattern, they apply to a single photon in a pure state. If we're dealing with entangled photons, a phenomenon we call coincidence counting becomes necessary. The quantum eraser experiment thus adds a new layer of complexity to our understanding of light's nature. So what does the quantum eraser experiment tell us? At its core, this experiment challenges our traditional understanding of light's behavior and causality. It demonstrates that a photon's path, whether behaving as a particle or a wave, can be altered in flight. This fascinating concept defies our standard view of quantum mechanics, unraveling a paradox that requires a fresh perspective. It's a revelation that pushes the boundaries of our understanding of light and quantum mechanics. Indeed, the quantum eraser experiment pushes the boundaries of our understanding of light and quantum mechanics. Don't forget to subscribe for more intriguing explorations into the world of science.